Hello and welcome to the fifth part of the tutorial series for the COVID-19 simulator developed as part of the EUVABECO project. In this scenario, we simulate the wave of infections with virus variant Delta in Poland. We compare a baseline scenario without any changes to a counterfactual scenario in which variant Delta emerges earlier in time. First, the baseline simulation is performed by clicking the Simulate button. After a short simulation run, the results are displayed. The Save button is then selected to save this scenario under the name Baseline. For the first counterfactual simulation, click the Scenarios button with the cogwheel icon. This opens 3 selection areas below the date settings. In the right-hand selection area, the Variant Modifications section is displayed. The variant Delta is selected. The emergence of the variant is shifted 75 days earlier. All other settings remain unchanged. Click Simulate again. Once the results are displayed, this scenario is saved under the name Delta 75 days earlier. After completing these steps, 2 simulations are available. Under the heading Simulation Results, the scenarios are compared. Using Compare and Add Comparison, both scenarios are displayed side by side. When looking at the results, several differences become visible. When the variant emerges 75 days earlier, in April 2021, the number of daily infections shows only a minor increase. This is because Poland had implemented effective measures to decrease transmission during spring 2021. These countermeasures were effective enough to reduce infections caused by the more transmissible Delta variant. At the same time, variant Delta caused more severe disease than the previous Alpha variant. As a result, more hospitalizations occur. Notably, extremely high peaks of infections and hospitalizations appear during the following winter. These results imply 2 things. First, if a highly transmissible virus variant emerges, mitigation measures can still be effective against infection. However, if it causes more severe disease, hospitalization numbers might still increase substantially. Second, however, these simulations highlight the limitations of the model. Setting scenario changes in the past while simultaneously simulating more than a year into the future leads to unrealistic results. The reason is that real-world conditions change significantly over long periods. These changes are due to virus variants, immunity, human behavior, risk perception, and testing practices. Our scenario alters the trajectory of variant Delta, but the model continues to assume that the underlying dynamics remain comparable. This introduces substantial bias in predictions far into the future. For example, the vast increase in infections in November 2021 would in reality have triggered the implementation of countermeasures. Additionally, the model assumes lasting immunity following infection. The sole exception is Omicron reinfections among individuals previously recovered from wild-type, Alpha, or Delta. In scenarios generating very high cumulative infection numbers, the susceptible population may become depleted, causing an artificial extinction of transmission. Therefore, long-running simulations can become misleading. Further limitations include the fixed demographic and testing covariates. In the simulator, age and sex distributions of cases remain at their historically observed values, regardless of the simulated scenario. Since these covariates influence progression to hospitalization and death, the model implicitly assumes an unchanged demographic composition of infections. Additionally, testing volumes and test positivity rates remain unchanged. In practice, changes in infection incidence would affect either testing number or test positive rates, or both.